Welcome to a Clockspring 3D tutorial on Vase Mode hex twist boxes. If you've watched the video titled Vase Mode is Great, you'll know what this is all about. Now, this model is available for paid download on My Mini Factory, but you don't have to pay, you can just make it yourself by following this tutorial. Now, if you want to pay for the download just to give me money, or because you don't feel like making it yourself, then those are perfectly good reasons to do so. However, I'd hate to think that anyone felt that they couldn't do it, because it's really easy, and we'll be going through step by step how to do this in Tinkercad. So if you don't have a Tinkercad account already, you'll need to go create one of those. So tinkercad.com, it is the easy, accessible, free, streamlined online CAD software, and I love it and you should love it too. It's really easy to get into, so if you don't have an account already, just go create one of those and I'll wait here while you do that. Okay, I'm going to assume that everyone's done and we're all good to go. So over to Tinkercad. So here we are looking at Tinkercad, and the first question is, where do we start? So let's look at what we're actually making here. We are going to start by just creating this twisty outer shape, the main shape for this whole box. And that's actually really easy because there's a built-in shape tool in Tinkercad to do exactly that. So let's use it. Now, if we look over on the right-hand side here, we'll see a drop-down from which we can select Shape Generators All. And that'll start loading up. Now somewhere in here, and I've done this before so I already know it's on page 6 for me. That may vary depending on the resolution and so on, and I'm running a fairly low resolution for this recording. Twisted Polygon is the thing that we want, so we can just click on that, drag it into the work plane, and there we go. Now we need it to be bigger, and it's tempting to just grab this handle and drag it out and maybe hold shift down at the same time and change it to whatever size we want it to be. However, notice how there's a slight discrepancy in these dimensions here, and that's because despite the fact that this object is radially symmetric, that bounding box changes depending on the orientation. Now, fortunately, this particular shape generator also has this panel on the side here on the right to control the dimensions. So we're going to use that because that will let us precisely control exactly how big this is. And where that matters is when we start trying to create two of these things so that one can fit inside the other. And their precision does actually matter. So let's make this 6 points because hexagons are cool. But really you could use anything you want. It doesn't matter. For the purposes of this tutorial, it can be any number of points. It'll work just as well. Okay, let's set the radius to 30 millimeters. Wow, is that really 30? Oh, I stretched it out, didn't I? See, that's the thing. If you drag these things out without changing, well, any distortions you make to the model remain despite making changes to the right-hand panel. So I'm just going to undo a few steps. See, it was effectively treating that current shape as being 20 millimeters across, where in actual fact, it was now 56.99. So let's undo that again. Back down to where it was. Okay, so now this is a bit more realistic. So now 30 millimeters across. That's better. And height. Let's go with 40. How do we like that? I'm going to ease off the twisting just a little bit and maybe make that 30 and minus 30. But all of these settings are arbitrary. You can use whatever you like, and the results that you get out of it may vary depending on the specifics that you use, but this is really easy to experiment with anyway, so make lots of them. Okay, so that is in fact a basic shape. That's all we need. Now, we obviously need to make two things. We need to make a lid and we need to make the base. And we're going to start with the base, just because it's where all the complexity is. So these finger hole things. Let's make those first. Now, you'll notice that each of these little insets are really just cylinders that have a truncation at the top at 45 degrees. Now, that is important because there's a limit to how much of an angle we want to have, how much of an overhang angle we want to have on a Vase Mode print, for reasons that we discussed in the other video, which I'm sure you won't have watched. So we're going to stick to 45 degrees here because that's a reasonably good compromise. So let's start by going on the right hand panel there, back to basic shapes. Find a cylinder. You know, I was going to grab the subtractive cylinder, but I'm going to grab this one instead. I mean, the only difference is whether by default it's selected as solid or a hole. So it doesn't really matter too much. Okay, I'm going to make this, say, about 15 on both axes. I have no idea what I actually used on this model. But again, it's arbitrary, so make it the way that you want it to be. Okay, then let's grab a subtractive block. Rotate it 45 degrees. I'm going to grab one of the handles and just drag it out while holding shift down, just because I want this block to be nice and large, because I'm going to use it to chop the top off this thing. Now, it's at this point that I'm also going to switch my view to orthographic, because when you're lining things up, it makes it a lot easier to see. And there we go. I'm also going to use the fit view to selection to zoom in, and I'm going to click on front to make sure we've got a nice aligned view. Okay, so just to be sure, we only have that block selected. Using the cursor keys to move in. That looks about right. Let's just change our angle to see. Yep, we are covering that thing in entirety. Select those two and group. Now, I did go to use Control G to group, but that doesn't show up well in the video. So I'm trying to use the on-screen controls where possible rather than using keyboard shortcuts. But the keyboard shortcuts are so convenient. Okay, now we're going to move this into place roughly, and it doesn't have to be exact, because we're then going to duplicate, and I'm going to use a keyboard shortcut for this and go Control D and flip that on that axis. Turn flip back off again. Going to use cursor keys to shuffle it over to the other side, and then we're going to group these two elements. And this is why we don't have to be exact, because we're going to center them once they're grouped, and that will keep them consistent, and that's really all that matters. It doesn't matter where exactly these things sit. What does matter is that they all sit in the same place relative to the center. So let's do that. So we're going to group those two. Now, just so we can see what's going on, I'm going to make the large block transparent. So we can see that these things are protruding into the middle. Let's select the lot, align. We'll center everything on that axis, center everything on that axis. Now, this isn't sitting, this choppy bit isn't exactly sitting where I want it to be yet, but that doesn't matter, because we'll start by making a whole bunch of these things, because I like the idea of having 6 of them spaced equally. So drag that angle around, and we're just going to type in here anyway, 120. And I forgot to mention, I did Control D to make that duplicate. And now that I've made one duplicate and translated it, or rotated it actually, I can do Control D again and get another one with the same shifts as the previous one had. So now we have equally spaced subtractive elements that aren't actually subtractive yet, but we will make them so. Select them all, turn them into holes, and I'm just going to group them as well for the sake of ease. Now let's have a look where they actually sit. Now I don't really want these to intersect with these lines down the side, because I'm concerned that when the lid of the box is placed on, that if there's any bits that stick out like that, that they're going to end up being caught at some point. So I don't know whether that's paranoia or not, but it's a design decision that I'm happy to make. So let's just have a look where they're sitting. So at the moment, This is absolutely intersecting. Let's take transparent off this again. Now there is a keyboard shortcut of pressing T, but I'm not doing that. Now if we rotate, we're rotating all of these elements around the middle of this thing because they're all centered. So we can happily just shuffle this around until it sits in a happy spot. Let's just make this a nice light color so we can see what's going on. So that looks pretty good to me. I like where that's sitting. Oh wait, no I don't. What's going on there? I'm not sure these are actually centered after all, are they? Well, they look centered. Well, clearly I was not giving enough consideration to where everything is at. See, this doesn't look right to me because these should all be sitting consistently in the same spots on each face. Well, that says it's centered. Oh, look at that. I didn't make this a hexagon after all. That's the problem. Now, you probably saw that when I first created it and went, oh my God, he undid too far. But it took me a while. Okay, now we can do this. Let's rotate. That looks good. Okay, and now they look consistent on each face as well, which is what we want. Select all of them and group. And there we go. So we have the basics. Now, that's not the only feature that this box has on the base. Next, we need to consider this chamfering on the tops. And this is one of the cool things with Vase Mode, is that, yes, we have these slopey bits up the top here, but because we're printing in Vase Mode, we don't have to worry about this internal geometry. We don't have to cut out things so that we just have this lip, and we don't have to carve out around these internal parts of the finger holes either, because that we get for free because we're printing in Vase Mode, which is really cool. So, next up, let's do the chamfering. So we're going to do the chamfering in a fairly similar way, in that we're going to create one object, reflect it over to the other side, center it all, and then duplicate it and rotate it. So we're going to use a roof this time, which is not a feature that I use very often, but it is arguably pretty useful. So let's rotate this thing so that it's got the orientation that we need, which is like that. And I want this to be about a 5mm horizontal chamfer. So let's just drag that. I was clicking, dragging, and holding down Shift to keep my my scaling uniform. Okay, now I'm using Alt while I drag this handle to keep the change happening in both directions. And now I'm going to align these two objects. So importantly, we want this choppy outy bit to be aligned to the top, and we need it to be to some degree along this edge, but it doesn't even matter if this roof element is aligned with that edge, because even if it is exactly aligned, because these sides are curved, we're going to get this irregular effect anyway. So it really doesn't matter. Again, as long as it's consistent on each edge, it'll look good. By the way, the purpose of this chamfering at the top is purely to make it easy to put the lid on. And that came from some of these earlier experiments that I did where I didn't have any such thing. And because it's Vase Mode and things flex really easily, it's really easy to find it difficult to put the lids back on. So this was another one that, yeah, so this was the same kind of deal where you've got to get it just right to get it back on. Whereas with this one, you get a ballpark and it slides on. So it makes a huge difference to the usability of that design. Okay, but back to this chamfering. So let's just move that there. Again, fairly arbitrary. Control D to duplicate. Flip that way. And I'm using the keyboard to move it into place. I'm going to group those two things like that. Select it all, align, center, and center. Now, it's important that we center on both axes because we want to be able to rotate these roof elements and have them rotate around the center of the object from which we're removing material. So now Control D to duplicate, rotate 120, Control D again, and there we go. So let's just select all and then shift and click to unselect the middle bit. Make those holes, select all, group. And there we go. Now, there's a bit more chamfering there than I'd really intended. Oh, look at that. You can see that they were a bit too far in as well. So we've ended up with these little cusps there. So let's fix that. Let's ungroup. You know, actually, let's just undo back to when we just had two of these things. And then double click to enter the group. I'm going to move it out a fraction. How's that looking now? That's much healthier. Okay. So select outside those objects and we're back to editing everything. Control D to duplicate. Drag 120. Control D again. And again, select everything. Shift click the middle box to deselect it. Turn all those things into holes. Select everything again. Group. And there we go. That's much better. So that is this middle part completed. So that's all we needed to do. Which takes us to the lid. And this is where that discussion from the other video is important, because we can't define this interior geometry. So how do we approach this? Well, we're going to start by just making a duplicate of that base object that we started with for the inside, because we know we're going to need pretty much the same thing but with slightly different dimensions. So let's do that. So we're going to Control C, Control V. Just move this one out of the way. You know, we can hide the base entirely actually. Hide. Okay, so ungroup. We can select everything except for that middle part. Delete. We can ungroup. Select those choppy 80 bits. And now, so you can see by the fact that there's no ungroup icon there, now we just have that base element. So the question is, what dimensions do we give this lid? Let's have a look at a more conventional twist box. So this is not a vase print, it's just a regular print. So this has geometry that we can define very easily. So we can define all of the measurements of the inside of this lid, and we can define all the measurements of this inner part as well. So we can say, okay, this dimension is whatever it is, and this is all the same with a tolerance of 0.5 millimeters at each spot. So that way, if we get it in just the right spot, there's a lot of surface area there, and not the flexibility that we have in a Vase Mode print. So that's easy because we can just specify exactly what we want at design time, and we don't have to think about the printer involved. But with this we do, because we can't specify any of this interior geometry. All we can specify is the exterior. So we need to know what extrusion width we're going to print this at, so that we can calculate how far it's going to be from this outer surface to this inner surface, so that we can size things to sit properly on top of this. So how far does that need to be? Well, as we saw in the other video, this 1mm extrusion version is quite different to this 0.4mm extrusion version. In both cases, I've allowed 0.5mm tolerance so that the parts can move against each other, so that the lid will fit neatly without getting caught. But this wall is much thicker, and therefore the overall width of this lid is much broader. I say much, we're talking about a difference of a millimetre. But in the scheme of things, it's huge. So the calculation. Okay, so we know that the extrusion width with a 0.4 millimetre nozzle is probably about 0.4 millimetres. I rounded it up to 0.5 just because it was easier. So it means that we've got 0.5, 0.5, it's 1 millimetre in total. And then we have the tolerance for the surfaces that touch each other. Now that's 0.5 as well on each of these surfaces. So 0.5 on this side, 0.5 on that side, which is a total of 1 millimetre there as well. So in total, we need to have this lid 2 millimetres wider than this base. Now, for the 1 millimetre version, we need to allow for 1 millimetre walls instead of 0.5. So over 2 opposing walls, that means that this needs to be 3 millimetres wider than the base for the same interior geometry. So let's go over to Tinkercad. Now over here in Tinkercad, so we have our existing lid object that we need to expand in every dimension. So rather than changing the radius here, which will essentially distort the shape because we won't be changing the height, we will use the handles to drag. So there are times when you want to drag with the handles, and there are times when you want to use those parameters on the right. And in this case, we want to use Shift. We want to actually click on the right handle. We want to use, okay, hold down Shift and drag that to 62. In fact, actually, we'll just go ahead and type this in. Now, because we had Shift held down, even typing is going to scale things uniformly, so that's fine. Now, one thing we need to deal with, though, is that we just resized the height as well. So this was 40, it's now 41 point something, 41.33. So we need to address that. And I'm going to do that with this big slabby object. And I'm going to move that up so that the base is 40 millimeters off the surface. Was that 40? Whatever this thing was. Group. And we are done. And that's it. That's everything. So let's just do a sanity check though. Let's put these things in place with each other before we actually print anything. So show all to bring the other piece back. I'm going to make this lid part transparent. Now bear in mind that we're printing the lid upside down, but it doesn't really matter because these things are symmetrical anyway, so it won't make a difference. But if you flip things around in here, you'll find that the orientation is not quite the same anyway, but that's all right. It's still symmetrical and it'll be fine. So, okay. Put these things together. Maybe we'll use some alignment tools, seeing that we have those. Okay, and let's just look at the top and rotate. I mean, this is, again, it's just a sanity check, so it doesn't have to be exact. But see, we've got some tolerance there. We'll also, let's move this up a fraction using Control and arrow up to move things. Now our snap to grid is set to 1 millimeter, so that moved it 1 millimeter up. And this base is probably going to be, what, 3 layers at 0.2, so it's probably going to be about 0.6 millimeters anyway, so roughly okay. And looking at that, that looks pretty good. That looks pretty much as I would expect. So from there, let's move this out of the way again. We just export as STL, and we do the same thing separately for that one, because of course we need to print them separately because they're Vase Mode objects. And while slicers will generally be able to handle having two Vase Mode objects on the bed at the same time, you won't get genuine Vase Mode because you can't have that gradual increase in height. Instead, it'll fake it by doing layer by layer with no infill and so on, which is not the same. And we're done. That's everything. That's the entirety of the design for this Vase Mode twist hex box. So I encourage you to make your own, change it up, improve it, make it different, and let it inspire you in some way. I hope it can inspire you in some way. Twist boxes in general are really cool, and at some point I'll do a tutorial of doing arbitrary profile twist boxes like these ones, although that will be in OpenSCAD rather than in Tinkercad, just because we start needing the advantages of being able to code things to get these done. But it'll be easy. It'll still be very easy to do. So on that note, please do post your own makes on Twitter. You can tag me, I'm ClockSpring3D on there. You can find my stuff on my Mini Factory, and you already know where I am on YouTube. So thanks for watching and enjoy!